Hi, in the next few videos we're going to talk about isomers. So to begin, isomers are molecules with the same molecular formula but different chemical structures. There are a lot of different isomers that you're expected to know for the MCAT, including structural/constitutional isomers, stereoisomers, enantiomers, diastereomers, epimers, anomers, and more. We're going to go through each of these one by one, starting off with structural/constitutional isomers. These are isomers that have different atomic connectivities. This means that the atoms are connected in different ways. And as a consequence of having different atomic connectivities, they will have different chemical and physical properties. Okay, so let's take a look at a few examples. Structural isomers can have different atomic connectivities based off different carbon chains. For instance, we can consider different forms of pentane, molecular formula of C5H14. You can consider N-pentane, where you just have a 5-carbon straight chain. You can also consider isopentane, where you have a 4-carbon chain and a methyl group attached. And you can also consider neopentane, where you have a single carbon in the center bound to 4 methyl groups. All 3 of these are structural isomers with the same molecular formula, but you can see how the atoms are connected differently. Another example we can consider is positional isomerism. This would be a situation where we can have C3H8O for our molecular formula. And we can consider, for instance, propanol. Right? Propanol, it's got 3 carbons, it's got 8 hydrogens if you add them up, and 1 oxygen atom. Here, the hydroxyl group is at the end of the carbon chain. You can draw a structural isomer where the hydroxyl group has a different position in the middle of the chain. Another example of structural isomers is where you have differences in the functional group. So for instance, we can consider C2H6O. And here you can have, for instance, ethanol. Right? Ethanol, the functional group here is an alcohol. You can also have dimethyl ether. And alcohol and ether have very different chemical and physical properties because they are completely different functional groups. Another example we can consider, for instance, would be C6H12, which could be cyclohexane, where you've got a ring structure, versus 1-hexene. In both cases, same molecular formula, but clearly very different structures due to atomic connectivity and different chemical and physical properties.